Okay, we're going to move on here quickly to the second example. Second example here asks us to find three new things. They're going to ask us to calculate midpoints, relative frequencies, and cumulative frequencies. First and foremost, let's let the cart go by in the hallway. This is making a lot of background noise. Okay, midpoints, and they should have a nice definition box here. Midpoint is the lower class limit plus the upper class limit divided by 2. This is no different than finding a geometric midpoint on a coordinate plane. X value plus X value divided by 2, Y value plus Y value divided by 2 would find the midpoint of a line segment. Exact same equation. So we're just going to go ahead over here in midpoint. And we already have our classes, our upper and lower limits over here. So we're going to use the ability of sheets to put equations in and do multiple calculations at once in order to make this faster for us. So we're going to just start with an equal sign. That's the symbol that tells Google Sheets we're creating an equation. And we're going to highlight this first class here, 59, plus the upper class limit, 114, and we're going to close the parenthesis, and we want to divide that by 2. And we get a midpoint, 86.5. Now, we can go through and type that repeatedly, but we don't need to, because we can drag that equation down the list, and it will tell Google Sheets to repeat that calculation over and over again. And it will repeat it with the new values that are associated with it. So if we click on the first one, we told it to use, and we could look, this up here is called our equation bar. It tells us we did C8 plus D8 divided by 2. If we go down one, it jumped to C9 plus D9. So it used the next row, which is row 9. Okay, so we're getting the value from column C, row 8, plus column D, row 8, divided by 2, and it gives us our midpoint. All right, so that's quick and easy. That's not a real difficult task to complete. The next one on our list is something called relative frequency. Relative frequency is nothing more than, think about finding a percentage. Okay, to find a relative frequency, we're going to simply take the frequency for the individual class and divide it by the total number of data values, or the total of our sample size, which we label as n. So we can do that very easily here. We're going to type equals. We're going to tell it to select the value from our frequency column, and we're going to divide that by 30. And it's going to give us a relative frequency. And if we drag and drop that down, it's going to calculate the relative frequencies for each individual class all the way down the list. Now, let's think about this. Each one of these represents the percentage or proportion of the total that class represents. So all of these values here should add up to 1 or 100%. So we're going to go in here to double check equals the sum. We're going to highlight our data set, our relative frequencies, hit enter, and it gave us 1. That lets us know that we are correct. Now I'm going to go ahead down here and highlight these things, and I'm going to change their color so that we know that those are things that we've calculated down there. Last thing we need to find is this thing called cumulative frequency. If we think of the word cumulative, cumulative means total or sum up to this point. So we're looking for the sum of the frequencies that occurred at the end of the first class, the sum of the frequencies that occurred at when we get to the end of the second class. Cumulative means we keep adding on to what we had. Think of when you ask a teacher if an exam is going to be cumulative or a test is going to be cumulative. That means is it going to cover everything up to this point? So cumulative frequency, here it's going to be easy, equals this number, 5. From there, what we want to do is we want to take the next frequency, 8, we want to add it to the previous frequency, 5. So we're going to tell it to do that, equals the next one plus the previous one and hit enter. So it did 8 plus 5 is 13. Now, if we drag that down, it should now add 6, the next one, to the 13 that's in the previous cell, and we should get a sum. Now, you could just do this manually. You could do 5 plus 8 is 13, plus 6 is 19. 19 plus 5 is 24, plus 2 is 26, plus 1 is 27, plus 3 is 30. Okay, but if you want to save yourself a little time and you want to set that little equation up in here, if I drag these down, I should get 30 at the end. 19, 24, 26, 27, 30. So there's your cumulative frequency column. The last thing that we're going to talk about, and I don't believe it's actually in example 1 or example 2. I'm going to add it in here anyways. This thing called class boundaries. It's really not a difficult concept. First thing we want to do is we want to look at our lowest class. And we want to look at this upper limit compared to the starting value of the second class, 114 and 115. We want to say, what's the difference between those two values? Well, pretty simple, equals 115 minus 114. We know is 1, correct? We want to split that in half. So we're going to take that number and we'll divide it by 2. Now, I'm going through the steps here, but I know that's really easy. But you might get a weird data set where things are in decimals, and it's not going to be a difference of 1, or a weird data set where you're counting by even numbers, so that the difference between classes would always be 2 instead of 1. The bottom line is we need to find half the distance between the two classes. And all we want to do is we want to stretch our class out. And there's a reason we do this graphically for setting up things called histograms later on. And it also helps with certain methods of counting frequencies. But it's really just a matter of stretching out the class. So all we want to do is we want to take this starting value here, 59, and we want to make it smaller by 0.5. Okay? And we want to take this value here, 114, and we want to make it larger by 0.5. We're just widening out our range of values, 59 to 114, half a value in each direction. Okay? Equals 114. This one we're going to add 0.5. So now our class boundaries would be 58.5, a little before 59, to 114.5, a little after 114. So all we did was stretch it out just a little bit wider. And we can drag and drop that down, and it'll calculate all of the class boundaries for us. And one of the things you'll notice when you see that is that diagonal values here are equivalent all the way down the list. And one of the things that's going to do for us is when we graph this data set, we graph these frequencies, it's going to create columns that are touching each other because there's no longer any difference of value in between the two groups. And that's one of the important characteristics of a histogram, is that the bars on it do touch each other. So that is a very simple way of calculating our class boundaries. We're just stretching it out, each class, so that this class ends, the first class ends exactly where the second class begins.